All right, we're going to talk about a concept of how accessible things are to other things. So we talked about how if a class exists inside the same package as another class, these two things can see each other and make use of each other. But it's not, quite that simple. So you can protect things by making them private. And so um, right now, by default, everything in this field is public. So all of this is to say, like, who has access to which things and in what ways. And the purpose of these like categorizations of access is just the same as it is in real life. You want some people to have access, trusted things to have access directly to parts of your house, but other people need to knock. And so public things are, anybody can come like look at my fence, right? But like if I have, like, not everybody can just waltz in and use my bathroom, and that's a private thing. Obviously, we all know the concept generally, and so that's why we use those words in programming. We have certain things that, like, are appropriate for certain contexts, and certain things that are not appropriate for different contexts and for different reasons. We'll get into those a little bit. Everything is by default public. So anything where you don't specify private is by default public, accessible to everyone. Outside classes can look at it and whatever. So this string is technically publicly accessible, which means that outside classes can change it directly. So for this video, I'm going to erase all of this stuff because it's going to be a little bit cumbersome. And then just start over, okay? So we're just going to create an instance of a myObject object called O. And then we're going to set that equal to a new myObject. And I'm going to give it a name of Rognus, whatever. And then this takes this parameter that is data in the type of a string, which is actually relatively complicated data. It involves multiple objects of type character or char. Which you don't really need to know, but what you do need to know is the computer takes kind of a lot of information to store this sort of data, and it's formatted in a particular way that the Java compiler expects, and blah, 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 blah. It's a specific type of thing. So you can't put a square hole in a round peg is basically the point here. And I'll show you that in a second. So like we can access this string.name in the same way that we reference methods. So like we can say o.name, because it's public by default, equals a new name. We can just set it equal to granddad. I don't even know what that word is. All right, granddadda. Great. And so now we can say o.say name. And if we run this, it's going to say the second thing, because we changed it directly. Now, that might not seem like such a problem. Great, we can access it directly. But what if a class of objects is making use of this object called O, like somebody else is using it, and they like accidentally try and set the name of the object to a number, 23. All right, the problem here is that this sort of thing can occur in situations where you don't want it to, and it can occur by accident. And you can see it's underlined here. And why is it underlined? Well, because we're trying to store a square peg in a round hole. We're trying to store data that is formatted in 32 bits as a number, so 32 on-off switches, in this container that's formatted to handle characters and words and stuff. Now, other languages handle this stuff differently, but in Java, you need to account for this kind of thing. And you need to block people from being able to do this. So we're preventing errors by what we do next. And so rather than do all this stuff, or have it to be careful, like which type of data is that? How do I store it? Anything? You can set up your objects in such a way as to control for that, so that the IDE prevents you from being able to make mistakes. And we do that by saying this string is private. Only the instance of the object that was created has direct access to the container called name. Everybody else has to knock. So in this case, it's going to get angry now because we cannot, an outside class no longer has access. This door is locked. So we have locked out the class. It can no longer make this mistake. It can no longer it'll catch it really quickly. 23, it's angry in a different spot. It used to be angry about this, now it's angry over here. No, you can't even try and change it. It's private. So how do we change it? Well, we already actually set up a method to change it. So we kind of set this program up correctly even before we needed to, and that is this set, didn't we change name method? Okay, so this method allows us to change the name. So we can still change it. So let's say, we still want it to be granddad. Well, we can do that. We just have to say o.changename. I think it's just change name to granddata. That's great. And so now it'll work again. But by doing this, we've protected the object's data. Data. Granny, whatever. So to get away with the confusion, do away with it. So this public versus private thing comes into play with methods, with data, with fields, etc. And like I said, all constructors are public by default. So we can just type those things in there, and you'll often see them. Well, most of the time, you'll see them written this way, public. But we could make this. I think that's enough for one video. I'll get into other stuff in the next video.